so let's talk about this one. Of all the dueling scientist questions I've seen, this one was just really weird. Usually it's not this awful. Okay, this one was just, man, I don't know. I don't know what they were thinking when they did it, but it was just tough. So let's kind of go through it. So here's question number 14 here. And it says, relative to the center of the protostar, does gravity more likely, blah, 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 blah. Notice it's doing this parallel structure here. So ACT does like this a lot. So what I want to look at is, does gravity likely accelerate particles inward or outward? So let's look. And if I look here, it says that the accumulates into. So gravity does it into. So that means that I can safely get rid of H and J, right? Because into means inward. Now the RP, on the other hand, the radiation pressure pushes away, right? So that means that I'm going to keep the one that's going outward. So letter G is what what did I do? Sorry. Letter G is what I want to do. Number 15 says, based on scientist two's argument, do particles more likely accrete near the equator or near the poles? Well, let's look. Based on scientist number 2 here, it says a disk forms in the plane of the protostar's equator. This results, blah, 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 gas from the disk to readily accrete. So it's the one that's near the equator. Now look, A and B both start off with near the equator. So you need to be careful here. And they do this all the time on the science section. Which is it by? Because the effective RP is increased there, because the effective RP is reduced there. It's because the effective RP is reduced there, right? Because otherwise it wouldn't be able to pull it in. It'd be pushing it out. Number 16. On a second, I got too many pages here. Question number 16 says, detailed surveys of star clusters near the Milky Way, blah, 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 shows no evidence of stellar mergers. Who would that go against? Well, that would go against scientist number 1 and scientist number 2, because scientist 1 says that you would have stellar mergers. Scientist number 2 says you'd have stellar mergers, right? Scientist 3 says, no, nothing going to happen like that. It's going to be limited to how much gas there is available. So only letter H, scientist 1 and 2. Question number 17, which of the most massive stars known would have a mass of 120? What would happen here? Well, if we look in here, scientist 1 says that it has to be a 20 ms, right? Every time we reach 20, we're going to have another stellar merger, right? And scientist 2 says every 40, a stellar merger. So if I take 120 divided by 20, I get 6. So it's got to be 6 stellar mergers for scientist 1. I eliminate A and B. I don't even need to really do scientist 2 because we know scientist 3 has to be 1 stellar merger, right? He says, or she says, it only happens once. So it's that elimination idea. Number 18, which of these would support scientist 2 but weaken scientist 1? Well, scientist 2's limit is 40, whereas scientist 1's limit is 20. So if I were to pick a 30 ms star, right, that would have meant that scientist 2 hasn't done a merger yet, but scientist 1 would have to. Now, if the star weighs this much, it means that it hasn't had a merger yet. And scientist 1 saying, whoa, 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 every time you hit 20, you need another merger. So H would decrease that. 19 is kind of dealing with motion, right? Scientists 2 and 3 agree that a disk forms around the protostar as a result of the protostar's what? Motion, because it says that, it talks about a rotation here somewhere. Yeah. The protostar rotates about its axis. To rotate about an axis, that deals with motion, kind of like a science knowledge question, but not totally. Which of these scientists would likely agree that the sun would have formed entirely by accretion? All three of them. There's no limit on our suns for this. That would be totally okay. All right, so this is our, that was the dueling scientist. Let's now do the, go to passage number 1. Okay, let's go to passage 1 and do a charts, tables, and graphs. And you're gonna have a feeling like, whoa, this one is very different than the other, okay? So I want you to do this passage. You're gonna have 5 minutes and 12 seconds on it. You may begin. Hopefully people felt that this passage was a little bit easier to do than the other one. So let's kind of look through it here. On the first question, it tells us based on figure 2, which is the one right above it, it says on average, where was the brightest surface soil found? Well, if I'm looking at this, the brightest surface was right here, right? Which meant it was a distance of 0 inland. So since we're not going inland, we must be at the coast site. That must be where we're at because that's as bright as it gets. Question number 2, it says, according to figure 2, or figure 1 rather, so now we're gonna look at figure 1, and it says the average relative brightness of the dorsal stripe, so I gotta make sure I'm looking at the dorsal stripe, right, was 0.25 and an inland distance that was closest to what? So I've gotta look at the dorsal stripe and 0.25, right? So if I go to 0.25 and find out where does that cross the axis at, looks like it's just a bit over 60. So I'm gonna pick 60. That's the best possible answer that we have there. It may not be the exact answer, but it's the best one that we can see. Question number 3, it says, according to figure number 1, so again, we're going back to the charts on the other side, the average relative brightness of the fur on the rostrum. So I got to look at the rostrum, which is, I guess its nose, kind of interesting. Occurred between which of the following inland occurrences? So the greatest change. So I'm looking at the rostrum, right? And they give us a lot of intervals, but it looked like the greatest change happens right here when we go from 50 to about, what is that? That looks like it's about 75 there. Huge change in brightness. So we are going to go with letter C, 50 to 75. Question number 4 says, based on figure 1, so back to those again, was the fur pigmentation lighter or darker inland than it was at the coastline? So we're looking at the ventrum, right? The ventrum is this graph right here, which is kind of like his, like, where you tickle him on his stomach there. And where was the greatest difference? Well, at the inland, really, really bright, right on the coastline. And as you went further and further inland, it got really dark, right? So the answer must be letter J. And you got to look carefully. Was a fur pigmentation lighter or darker inland than it was at the coastal site? So inland was darker, right? So we got to read carefully that it says the inland than it was at the coastal. So we're comparing inland to coastal. The inland, it was darker. Notice H is this also says darker. It's this parallel structure. So here it says the bottom one was less. That's what we want, not greater, but less. Be careful with that. Number 5 is our very first science knowledge question. It's called evolution, right? What would best explain the geographic variation? Well, the mouse is less likely to be found by a predator. And if it's not being eaten by a predator, it's more likely to produce more mice, which would pass on its pigmentation traits, right? If it's eaten by the predator, it's gone. That's why I don't see a lot of albino mice out there running around, probably because they're pretty easily spotted by predators. Now, that is not to say there's not albino mice out there, but they're not as prevalent. Question number 6 says, based on figure 2, so we know to look at figure 2, on average, was the surface soil at the coastal site darker or lighter than the standard that was used for comparison? I found question 6 to be a little difficult. I had to look carefully, and right below it tells me, compared to a standard that was assigned 100%. So 100% is the standard. If we're at the coastline, meaning we're 0 distance inland, we're only at 75%. So we're a little bit darker, right? We're a little bit darker. Letter J. All right. Mr. Williams, are you there?
I'm here.
All right.